Hello everyone, welcome back to College Algebra. We're going to continue working through the properties of real numbers. This time moving on to the operations of real numbers. So last video we learned about the types of real numbers there were, the sets, there's whole numbers, there's natural numbers and whatnot. And we learned how to identify them using set notation. And we're going to continue to use that notation to identify what numbers are required for certain situations. We may have different expressions that can only be true when certain numbers are used. So that information will be used continually going forward. But now we kind of backtrack a little bit. So set notation might be weird to some people, you might not be used to seeing that. But this stuff here, this should be a walk in the park. So we're out of formality. We're going to go through these next few lessons to have a complete lesson or course on the prerequisites of algebra. So this section 2, operations on real numbers, part 1. Addition and subtraction of real numbers. You might be thinking, this is so easy. Why would you want us to cover that? Because a lot of people actually may not understand that algebraic, what you would say, the formula for subtraction. You might not even realize that subtraction is simply the inverse of addition. And some people don't realize that, and it makes a deeper mathematics more difficult for other people. So we'll see when moving forward, when we get past the prereqs to get into more hard algebras and calculus and whatnot, you'll see that knowing these pre-algebra things will make it so much easier. So without further ado, let's start. Starting with the addition of real numbers. What is addition? Addition is when you take two real numbers. Remember what real numbers was. We have whole numbers. There are natural numbers, integers, rational numbers, irrational numbers. So when you take two real numbers and put them together, you are adding them together. There is a more formal word that's actually used in mathematics for the addition of two numbers. It is called a sum. When you sum two numbers, that is, when you add two numbers together, you end up with a sum. The sum is your answer of two numbers being added together. So if I were to say a plus b, what is a plus b? A plus b is your sum. That is your sum, the answer to your addition problem. So when you add numbers together, you can add numbers of like signs or different signs. What I'm saying is that you could add positive numbers together. You could add negative numbers together. You can even add a negative number to a positive number, or vice versa, a positive number to a negative number. And so when you add these numbers, let's start with this. So let's focus on adding like numbers first. So you have two numbers with the same sign. Let's start with the easy one, positive signs. So we have two numbers here. Let's go with 3. Let's get a different marker. I like yellow. Where's yellow at? All right. Say we have 3 plus 2. Super easy, right? 3 plus 2. We have two positive numbers. How do we know this 3 is positive? Because there was no sign in front of it. We know this 2 is positive because there's a plus sign in front of it. And it needs a sign, because if we don't have the sign there, we may mistake this for 3 times 2. Or we may mistake it for 32. So you have to have a sign right there to identify that this 2 is positive. But this 3 doesn't require a sign if it's positive, because there's nothing in front of it. So if we have 3 plus 2, we will go on to say that the sum of 3 plus 2 is 5. Super easy. Doesn't matter how small or how large the number is. Say we have 0.1 plus 0.4. If you have 0.1 plus 0.4, our sum would be 0.5. Super easy. Let's throw a rational number in there. Say we have 1 over 4 plus 2 over 4. Now, without getting the rational numbers too much, we will have a section dedicated to those. So I picked the easy one. When you have the same denominator, you could just add the top numbers. So this becomes, you keep the denominator because the denominator is the same, and you add the top numbers. This becomes 3 over 4. So summing or adding, I should say, positive numbers are super easy. Let's check out negative numbers. How do they work? Now, we first started with 3 plus 2. What if we had negative 3 plus negative 2? Now, something I need to point out. This 3 now has a negative sign in front of it because we need to identify that it is not positive. It's negative. This 2 has a negative sign in front of it to differentiate it from this addition sign right here. You don't want to get this 2 confused with this plus sign to make it think it's positive. So what a lot of people do, and you'll find this in most math books, if not all math books, you will see it in parentheses just to help separate it from that plus sign so you can know, okay, that is a negative 2 right there. So we have a negative 3 plus a negative 2. When you are adding numbers and both numbers have the same sign, you keep the sign. So if both numbers was positive, such as 3 plus 2, you would keep the sign positive and have 5. But if the signs are negative, you still keep the sign. So we have negative 3 plus negative 2. So our sum is negative 5. You keep the sign. The sign does not change one bit at all. Not at all. Same with decimal numbers, same with rational numbers. Say we had negative 2 over 7 plus negative 3 over 7. What does this give us? Without realizing, I used the same numbers, negative 2, negative 3. I didn't even realize it. This gives us negative 5 over 7. You keep the sign. If the signs are the same, you keep the sign. What if we have different signs? What if we are adding a negative and a positive together? All right, addition of unlike signs. So if you remember from last video, I introduced absolute value. Now, absolute value isn't usually thought of as a mechanism to find the sum of two numbers with different signs, but it works. And before I end this video, I will introduce absolute value as a construct for something used more commonly as. But for now, I am going to show, let's use a different color. I'm going to show how absolute value can be used to help figure out what the addition of two sums are. So what we can do is we can put everything in absolute values and subtract the two numbers. And then we keep the sign of the largest number. So, for example, say we have 12 plus negative 7. All right? 12 makes make that a little clearer. 12 plus negative 7. How do we do this? We subtract their absolute values and you keep the sign of the larger number. So, we immediately see the largest number. 12 is the largest number and it has a positive sign. So the answer is going to be positive. Now we subtract their absolute values. We have the absolute value of 12 minus the absolute value of negative 7. This leaves us with, what is absolute value of 12? That is 12 minus, what is the absolute value of 7? 7. This leaves us with 5. So the answer to 12 plus negative 7 is 5. Let's swap it around. Say we have negative 13 plus 6. Negative 13 plus 6. Let's get their absolute values. We have absolute value of negative 13 minus 6. And you could draw your absolute value bars a little bit bigger to make them more obvious. I have a bad habit of making my absolute values look like ones. Should really break that habit. So we have absolute value of negative 13 minus 6. So what is the absolute value of negative 13? That is 13 minus absolute value of 6 is 6. This leaves us with, what is our largest number? Largest number is 13. So it's a negative number. So we're going to keep the sign. The negative, what is 13 minus 6? That leaves us with 7. Negative 7. So it's kind of using absolute value to find the addition of unlike signs can be kind of annoying. After you do it so long, you'll be able to do something like this in your head, and you'll just know, okay, let's just subtract the two numbers, and we'll keep the sign of the largest. But why do that when you could just learn subtraction, right? Instead of thinking that, hey, let's add a positive and a negative number together, why not just swap it around and subtract the negative number from the positive number? That's what subtraction is. Subtraction is the how would you say it? It is the addition of inverse numbers. That is subtraction. So let's jump down here and pull my little subtraction symbol up. Let's go right here. Definition of subtraction. Let's just jump right here. What is subtraction? What is the answer to a subtraction problem? The answer to a subtraction problem is your difference. Your difference. That is the answer to a subtraction problem. The answer to an addition problem is a sum. The answer to a subtraction problem is your difference. So we know basic subtraction. We should all know that. So if we have 7 minus 5, we should know, okay, 2. If we have 3 minus 2, you should know, okay, that's 1. You know that. What is the definition of subtraction? Using the knowledge that we have used with addition, we could say, get this pen right, we could say, if we have A minus B, let's make this a little bigger so we can know, hey, we're talking about a definition here. If we have A minus B, how do we define this as a subtraction problem? We could say that A minus B is the same as saying A plus negative B. A minus B is the same thing as saying A plus negative B. What does that mean? Looking at this problem, I can see that when you are adding a negative number, this addition assimilates into a negative sign or a subtraction sign. So when you see an addition of a negative number, you immediately assume subtraction. So going back to a previous problem, let me scroll up instead of scrolling down. So we had, over here, let's use another number, another marker. Let's go with red. Say we have 12 plus negative 7. So we have 12 plus negative 7. It's the same as saying 12 minus 7. Now let's check this one out. Check this other one out. This one here, we swapped it backwards to have the negative sign in the front. So we had, y'all can hear that? That's thunder. So we had negative 13 plus 6. What's another way of writing this? I could just simply, and you will see this a lot in mathematics. I should just go ahead and make a side note right here. More often than not, you do not want your expression to start with a negative sign. And you will try to do everything you can to get that negative sign out from the front of the expression. Sometimes it can't be helped. Sometimes you just simply have a negative answer. But when you're trying to simplify or solve for a certain equation and end up with another equation, you really don't want this negative sign in front. You want to try to get rid of that. So how can we get rid of that? Easy. We can rewrite this as 6 minus 13. And that will give us our negative 7. Cool, huh? So you can see that subtraction is not a new operation separate from addition. It's simply just a modified form of addition involving negative numbers. So if we think of all real numbers, all the negative, so we got all the negative side and all the positive side. We could add all these numbers together. We're essentially using subtraction, not even realizing it. Pretty cool. Let's do a few practice problems. Let's throw a few out there. I don't want these early lessons to be consumed with practice problems, but sometimes practice problems are exactly what we need. And sometimes we just like doing math. I like doing math. It doesn't matter to me. So, say we have negative 6 plus negative 3. What do we have? We have a negative and a negative. Do we keep the signs? Do we keep the sign of the larger? What happens? We have two negative numbers. So the sign does not change. We are ending up with negative What is 6 plus 3? 9. 9. Negative 9. So what if we had 3 plus negative 7? Okay. How can we write this? We have your 3, and you have addition of a negative number, so we could say minus 7, which equals, what is 7? What is 3 minus 7? Negative 4. How would you do that in your head? Check this out. You take your absolute value. I'm pointing at the thing as if you can see it from right here. You take your absolute value of each one. 3 minus 7. Absolute value of 3 minus 7. You have 4. And then you keep the sign of the larger 1. Eventually, you'll be able to do it in your head. I'm pointing at my. I'm doing all kind of weird stuff today. Eventually you can hear it. You can see it in your head and do it geometrically. You could, like me. I'm weird. I have like a visual number line on my head, and these little numbers I could just kind of see it and know immediately where they go. Do enough math and that'll become your reality. You'll be able to do this with these people say it's like, oh, I'm too old to do this. Oh, I'm just not good at that. I know someone at my workplace, she says all the time, like, I'm just not good at this. I'm thinking like, you're not good at it because you don't do it. You put yourself to it. You study. You give yourself the time, 20, 30 minutes a day, and watch how good you get it. It's not hard. Stay off of TikTok all day. That's my point. All right. Moving on. Controversial subjects. Let's do some subtraction problem. Let's say we have 5 minus 9. How can I think of this as an addition problem? 5 minus 9. We can look at this as, remember, we have A minus B is equal to A plus negative B. So I can look at this as saying 5 minus 9 is equal to 5 plus a negative 9. What would we do then? Subtract the absolute values and keep the sign of the larger. I see subtracting these absolute values, I see 5 and 9. There's a difference of 4 between 5 and 9. And then I would see the sign of the larger, negative 9. So I see negative 4 is being a difference. Absolute value can be used as a construct for distance. Why? What is distance? Distance is the distance. Distance is the number of units from point A to point B. There we go. The number of units from point A to point B. For example, if I want to say how many units does it take to get from this point here to that point there? How many units is that? That is 1, 2, 3, 4, 5, 6, 7 units. So distance, usually marked as a lowercase d, equals 7. Cool, right? That's just distance. Distance is 7, you know? Here's a cool thing. Distance is never negative. I keep looking at the camera. I gotta get out of the habit. I keep looking at the screen, not the camera. Distance is never negative. You will never have a negative distance. If for some reason you're doing some kind of computation and the distance does end up with a negative number, say for example if we had negative 7 instead, that does not mean you move less than 7 units. It means you move 7 units to the left. And if it's positive, you move 7 units to the right. So that's what negative numbers mean in reference to distance. But we're not worrying about direction right now. Direction has distance plus direction involves velocity, I believe, if that's correct. I'm not brushed up on my physics. So, but we want to make sure we don't end up with negative numbers because we just want to know how far it is to walk from my house to the store. So, and the way we get rid of the negative number is we use absolute value. I'm trying to write that as if I can write script talk at the same time. Okay, absolute value. I haven't had my morning coffee yet. So, absolute value. We use absolute value to define the distance from point A to point B. How? How do we do that? All right. What we're gonna do is wrong button. I'm going to pull up another number line. Oops, that's next video's lesson. Y'all got a sneak peek. So let's go ahead and mark these right here. Let's say we have, start with 0. We got 16. I don't think we needed that many. But for now, let's just use 16. So, say our house is at point number 4. And the grocery store is at point number 13. I wanted to know the distance from 4 to 13. How do we do this? I'll show you how. You start with the larger number. So we have the absolute value. We all got to start with absolute value, right? Because we're working with absolute value. We're working with distance. We want a positive number. So let's start with the larger number. Why the larger number? I'm going to show you why. So from 0, you want to find this distance. So to find this distance right here, we need to find the distance from 0 to 13. And we need to get rid of this distance, and then we will have just this distance, this number right here. So let's get all the distance from 0 to 13 minus 0 to 4. So get rid of the 4. This will land us with absolute value of 9, which equals 9. Is that correct? Let's find out. 1. Let's see how. 1, 2, 3, 4, 5, 6, 7, 8, 9. It's correct. So from my house to the grocery store is 9 units. So what did I just do? What did I just show you up here? I came out the blue with this stuff. This is an idea that I've used to carry me forever, and it's used in all math. So get used to it, because I'm going to use it too. So what we did was we counted the distance from 0 to 13 is 13. And we subtracted the distance we did not want. The distance from 0 to 4. We wasn't worried about that. So if we say, this is what we do. Check it out this way. Check it out this way. The grocery store is 13 units from 0. My house is 4 units from 0. What's the difference between the grocery store and my house? I found that you can get the distance from my house to the grocery store by taking the whole distance from 0 to the grocery store and subtracting the distance from 0 to my house. What I did, let's erase all this again. What I did was I took this distance from the store to 0, and I subtracted 4. What does that mean? That means I got rid of this. I didn't want that. I don't want nothing to do from my house to 0. So I was able to take from 0 to the store, get rid of 0 to my house, and we are left with my house to the store. This is what you call working geometrically. You're able to find out using imagery, because I feel like that helps you mathematically amazingly. So I found out that we can see that we are 9 units from my house to the grocery store. Does this make sense? Please let me know in the comments if this does not make sense. I hope it does, because this has helped me so much in my study of math. Let's go ahead and do another one. This time we're going to add a few negative numbers. My mic keeps cutting out. I don't know why. If anybody knows why, if anybody has any tips, let me know. Alright. So this time we're going to go put 0 right here. Alright. Let's switch to another marker. Let's go with lime green. No. Let's go with yellow. Alright. So, say we are at -3, okay? And the bookstore is at 5. Cool? So we have -3 and 5. This time we don't have a 0 to use as our origin. Uh-oh. What are we doing now, huh? How do we find the distance between my house to the bookstore? How do we find the difference, or the distance, I should say? What we can do is we can take the absolute value of each number and add them together. So what does that do? Let me show you this. So we do still have origin. We do still have O, 0. It's just not in the beginning like we used with the other example. Now, what we can do is we can take this distance and this distance, take the absolute value of both those distances, and add them together. So we have the absolute value of -3 plus the absolute value of 5. I almost made a mistake right there. Leave in the comments if you noticed what I was almost made a mistake with. So, absolute value of 3, -3, the absolute value -3 plus the absolute value of 5. How does this work? So check this out. We have the absolute value of 3. What is the absolute value of 3? It is the number of units of 3 to 0. That gives us 3 plus the absolute value of 5 is the number of units from 0 plus 5 equals 8. So what we did is we took this absolute value and added it to this absolute value, and that gave us our distance from home to the bookstore. So whether we have 0 as a point marker or not, we can use it as a way to find distance using absolute value. Absolute value is something that, while it can be kind of annoying when you see it pop up in the example, in the expression or something, it's helpful because it helps identify what direction we need to work with. If we have an absolute value, we know, oh, okay, we need positive numbers. That's how I like to think of it. That's how I like to think of it. When you have absolute number, we're trying to work with positive numbers. We don't want for example, this might be I don't know if you've seen graph work, you might be able to recognize this. Absolute value, if you have absolute value, what does it look like on the graph? That's what it looks like on a graph. You have absolute value of x. So when if you take -1, you can see notice that this is your x-axis, this is your y-axis. Notice how no matter what it is, it's always positive. It never goes, the y value, I should say. So yeah, y equals absolute value of x. So y will always be positive no matter what value of x, whether it's on the negative side or the positive side. No matter what value it is, it's always positive. So when we do graphs, when we finish with prerequisites, when we get into equations and inequalities and etc., you'll see this example, and I'll be able to explain it more, to be a little bit more rigorous in how we evaluate and look at absolute values and stuff. And we'll have a lot more examples, I promise you. You will not have just 2 or 3 example videos. You will have lecture videos, and then you will have like an hour-long video or 2-hour-long video of nothing but examples, because some people like that. That's what some people want to hear. So you know what? That's what I'm going to do. Cool, right? So this might take a long time for me to get there. I'm a busy man. I work a lot. So that was, let's go back to the fun. This was addition and subtraction. I hope you enjoy this. I hope you do. I hope this is helpful, at least enjoyable to the least, I feel like most of us, if you're in college, you probably got this part down, and you're probably just waiting, saying, why don't you just go on to calculus already? Because I like the small stuff too, fundamentals are fun, I think so. So, my next lesson will be multiplication and division of real numbers. I hope you enjoy this, and we will see you next time. Bye-bye. Bye-bye.